All right, let's just jump right into this explainer. Today, we're tackling the actual hard financial metrics used to figure out climate transition risks, specifically what this means for the coal industry's capital operations. If you've ever wondered how these massive global climate policies actually translate into hard math on a corporate balance sheet, well, you are in the exact right place. We're going to break down exactly how this industry measures the viability of, well, what's currently buried underground against a regulatory landscape that is shifting incredibly fast.
So think about this. What happens to a coal company's value when carbon suddenly gets a price tag? I mean, this is literally the million-dollar question, maybe the billion-dollar question we have to answer when we're looking at the existential regulatory risks facing these highly energy-intensive operations. We're talking about a fundamental ground-up shift in how assets are valued today. You really can't just look at how much coal a company owns anymore. You actually have to ask, are they even going to be allowed to burn it?
To figure that out, here's our quick roadmap. We're going to hit the climate risk reality, stress testing reserves, the 3 IEA scenarios, calculating embedded carbon, and finally, how companies future-proof their capex. All right, part 1, the climate risk reality. Let's start with a foundational reality here. Global efforts to limit greenhouse gas emissions could massively reduce both the demand and the price for coal. And why does this matter so much? Because as regulations get tighter worldwide, these highly profitable assets that are just sitting there in the ground could potentially be left completely stranded, meaning they become legally or economically unmineable. Now, to truly wrap our heads around this risk, we've got to define exactly what a company has down there. And that means understanding the very strict difference between proven and probable reserves. Proven reserves, those are computed from really detailed sampling. The size, shape, depth, the mineral content, it's all well established. It's practically a sure thing. Probable reserves, on the other hand, are based on less adequately spaced sampling. So it gives a lower but, still fairly high degree of assurance. Basically, it's the difference between saying we know exactly what's down there versus we have a highly educated, really confident estimate. And let me tell you, that distinction is absolutely vital when we're talking about accurate valuation. Moving on to part 2, stress testing reserves. Okay, what's super interesting about this next phase is that we actually have to stress test these assets. Think of it like stress testing a bridge in a hurricane, right? But instead of high winds, we're testing against high carbon prices. We really need to see just how sturdy those proven and probable reserves are when the economic and regulatory environment gets, well, incredibly aggressive. Now, the SASB standard recommends a specific reporting matrix for investors to visualize this, to see exactly how future price scenarios impact the economic viability of both proven and probable reserves. The setup literally forces a company to map out their specific coal products against multiple potential futures. So this isn't just some academic exercise, it's a hard, practical requirement to visualize how a potential price on carbon completely changes the math on whether it's even worth digging that coal out of the earth in the first place.
Which brings us to part 3, the 3 IEA scenarios.
So, to actually fill out that sensitivity table, companies don't just blindly guess what the future looks like. That'd be a disaster. Instead, they use 3 specific future price trajectories published by the International Energy Agency's World Energy Outlook. Doing this ensures we get standard apples-to-apples stress tests across the entire industry. Let's look at how this builds sequentially across a timeline of scenarios. First, you've got our present baseline, the current policy scenario. This assumes literally 0 policy changes from today. Next, we look at the new policy scenario within that 5 to 10-year window, which assumes announced national pledges and subsidy phase-outs actually happen. And finally, projecting 20-plus years out to a highly aggressive future, we hit the sustainable development scenario. This timeline gives investors a really clear picture of how asset values might just completely degrade as global regulations tighten up. Let's zoom in on that last most dramatic scenario for a second. The framework defines the sustainable development scenario as assuming an energy pathway that is completely consistent with the goal of limiting the global increase in temperature to 1.5 degrees Celsius, specifically by limiting greenhouse gas concentrations. So the absolute critical question here is this. If the world fully commits to this 1.5-degree limit, how much of a company's currently proven coal reserve suddenly becomes totally unmineable because of climate regulation? The reserves are physically still there, sure, but economically, they just vanish. All right, part 4, calculating embedded carbon. To really answer that question about stranded assets, we've got to drill down even further and calculate the exact amount of carbon liability currently sitting unmined in the ground. Because, honestly, you simply cannot price a regulatory risk until you precisely quantify the carbon that's about to be regulated, right?
So the key here is a specific equation required to estimate the potential carbon dioxide emissions embedded in those proven coal reserves. Ready for it? E equals R times V times C. I know, it looks super simple, but this formula, which is derived from Meinhausen and colleagues, this is the absolute bedrock of carbon risk valuation in the mining sector.
Let's de-jargonize this math a bit into 3 simple steps. Step 1, we take R, which is the physical quantity of proven reserves, measured in gigagrams. Step 2, we multiply that by V, its net calorific value. Think of this essentially as its energy value in terajoules per gigagram. And step 3, we multiply that result by C, the effective CO2 emission factor, or the specific carbon factor. To put it simply, quantity times energy times carbon. That whole calculation gives us our total embedded carbon liability. It's honestly a brilliant, elegant way to measure exactly what is sitting right there below the surface.
But wait, what if a company doesn't have perfectly precise data for their specific mine? Well, the framework actually has a built-in safeguard for that. If a company lacks specific entity-level data, they just seamlessly rely on default values published by the Intergovernmental Panel on Climate Change, the IPCC, to complete this engineering estimate. This standardizes the carbon content in the net calorific values, which ensures consistency across the board for everyone. It also specifically measures potential CO2 only, keeping the focus strictly on that embedded liability rather than all the downstream greenhouse gases.
And finally, part 5, future-proofing CapEx.
This brings us right into the boardroom. We need to understand how these strict climate regulations directly dictate a company's capital expenditure, or CapEx strategy, because all of this incredibly precise math we just went through, it ultimately feeds into how hundreds of millions of dollars are spent, or saved, right now, today. Management has to analyze how different regulatory structures are going to restrict future demand and shift capital decisions. Take a direct carbon tax, for instance. That's a fixed fee on embedded emissions. It's highly predictable. But contrast that with cap and trade, which is a market-based system of tradable emission allowances, where the cost is always fluctuating. Exactly how these specific policies are designed, both locally and globally, will fundamentally alter the cost curve of mining forever.
And depending on how that price and demand scenario planning shakes out, companies are going to radically alter their strategies. These metrics directly impact the development of new assets, the acquisition of properties with proven reserves, buying unproven resources, and even ongoing exploration activities. Think about it. Why spend an absolute fortune exploring a new site if your embedded carbon calculation, combined with that IEA sustainable development scenario we talked about, tells you the coal is going to be an unminable liability by the time you even reach it? As global policies continue to shift so rapidly, it really leaves us with a final, pretty sobering question to consider. If climate regulations accelerate to meet that 1.5-degree target, are the proven, highly profitable reserves on today's balance sheet just destined to become the stranded, unminable assets of tomorrow? The data and the formulas are all right there, waiting to be stress-tested. It's entirely up to investors and operators to do the math today, before the regulatory market does it for them tomorrow.